Hello, folks. As you can see, the next topic we'll be going over is multiplying rational numbers. So unlike adding and subtracting rational numbers, when we multiply rational numbers, we don't need them to be comparable, right? So when we were adding and subtracting rational numbers, they needed to have the same denominator because we needed them to be the same size in order to add them. But when it comes to multiplying, well, we can actually multiply unlike rational numbers. Right, so remember when multiplying fractions, we multiply the numerators and we multiply the denominators. So basically what we're going to do is when we need to multiply a rational number, we are just going to multiply straight across the top and straight across the bottom. So for example, if I wanted to take 2 over 3 and multiply it by 1 over 4, well, I just look at the two top numbers, so 2 and 1, and I multiply those. And I look at the two bottom numbers, 3 and 4, and I multiply those. When I multiply 2 and 1, I get 2, and 3 and 4 gives me 12. So then if I were to simplify 2 over 12, right, both of these numbers are divisible by 2, I would get 1 over 6. So if we looked at a couple of examples now. So here's my first example, 6 over 3 times 3 over 7. So if I, again, looked at the tops and the bottoms, that would be 6 times 3 over 3 times 7. And that gives me 18 over 21. Now 18 and 21 are both divisible by 3, so I could simplify this a little bit and divide that by 3 and divide this one by 3, and I get 6 over 7. Now there's something interesting about this example, because if we look at these numbers that we get, 6 over 7, and we look at the numbers we started with, we had a 6 and a 7, right? And it's not a coincidence that the numbers that I then divided by were 3 and 3, and over here we had a 3 and a 3. So when it comes to multiplying rational numbers, yes, we can multiply across the top and multiply across the bottom and then simplify, but we can actually do some simplification before we multiply. So if I look at this step here, and if I were to kind of take this and rearrange it, so 6 times 3 is the same thing as 3 times 6, right, over 3 times 7. Now, look at what happens. I have a 3 divided by a 3. And when I divide something by itself, it turns into 1. So I now am left with 6 over 7. Right, so there's two ways of looking at these multiplications, and I prefer to cancel first, but not to say that you have to. Sometimes you may want to actually do the multiplication and simplify. It's up to you, but pick the strategy that makes the most sense for your needs. All right, we take a look at a couple more examples. So for example, 5 over 7 times negative 3 over 4. Now that we have this negative, right, the rules are not going to change. So 5 times negative 3 over 7 times 4 is negative 15 over 28. And we talked about negatives with rational numbers before, the negative being in the top and the negative being in the bottom, or just it is negative of 15 over 28. Right? And then if I look at one more here, negative 6 over 3 times negative 3 over negative 7. So again, negative 6 times 3 over 3 times negative 7. And again, much like the first example, what we see here is we see that we have a 3 in the top and a 3 in the bottom. So what we can do with that is 3 and 3 can simplify, or they can divide, and just leave me with negative 6 over negative 7. Right, now, there's a problem with this, because what happens when we divide a negative by a negative? Well, it's really similar to what happens when we multiply a negative by a negative. A negative divided by a negative is a positive 6 over 7. Okay, so much like with in whole numbers, right, with integers, with natural numbers, right, we have these rules where when we multiply or we divide positives with negatives, we can expect certain answers. So a positive multiplied with a positive will give us a positive. A negative multiplied by a negative will give us a positive. But a negative multiplied with it by a positive, or a positive multiplied by a negative, will both equal a negative value. So for example, in this one here, a negative multiplied by a negative is 33 over 35, and it is going to be a positive answer. Right? 11 times 3 is 33, and 7 times 5 is 35. Now, with these numbers, when we have these mixed fractions, right? Again, much like with your addition and subtraction, what we're going to want to do is turn them into improper fractions first, and then do the multiplication. So for example, 2 and 2/3, well, 2 times 3 is 6, plus 2 is actually 8/3, right? And 1 and 4/3, 1 times 4 is 4, plus 3 is negative 7/4, right? And this negative here applies to the whole fraction. So when I have this improper fraction here, it will also be negative. So now when I do a multiplication, well, a positive multiplied by a negative is a negative. So then I just need to multiply across the top and multiply across the bottom. Now again, what will happen here is we can do some simplification before we do that multiplication, right? 4 and 8 can both be divided by 4. So when I do that, this turns into a 2 and this turns into a 1. Now my simplification will be, we won't need simplification because we've already done it. So 2 times 7 is 14, and 3 times 1 is 3. And again, a negative multiplied by a positive is a negative. So negative 14/3. Okay, so when it comes to multiplying decimals, right, a lot of you are probably more comfortable with the decimals than you are with the fractions. And again, that's not because fractions are necessarily more difficult, but simply because you're just more used to decimals, right? Fractions take practice, but once you've practiced with them, they make your life so much easier. So to multiply this, there's two strategies, and my preferred strategy is actually to work with the fractions, right? So this 8 right here is in the tenths position after your decimal. So 0.8 is actually can be rewritten as 8/10. Right? And the same thing with this 0.4, right? This 0.4 is in the tenths position. So negative 2.4 can actually be rewritten as negative 24/10. And now to do this multiplication, right, we just need to simplify these two fractions. So 8/10, 8 and 10 are both divisible by 2, so this is 4/5. And 24/10 are both divisible by 2, so this is negative 12/5. And now multiplying across the top, we get 48, and multiplying across the bottom, we get 25, and then a positive multiplied by a negative gives us a negative, right? But there is more than one way to answer this question, right? So for those of you that do not want to convert to fractions, you can also multiply these decimals by just considering the whole numbers for a second. So instead of writing 0.8, let's just think about what is 8 times negative 24. 24, sorry, not 2.4. Negative 24, right? So maybe you just want to consider the whole numbers for a second. So 8 times negative 24, let me just use my mental math skills here for a second, is negative 192, right? But then we have to consider that, well, this 0.8 times negative 2.4 is not going to be negative 192, right? There has to be a decimal in here somewhere. So where does it go? Well, we ask ourselves, how many times did each of these decimals move? Well, this one moved once, and this one moved once in order to get 8 and negative 24. So what's going to happen is that this decimal that would normally be right here after the negative 192 moves once twice, right, to make up for the 2 moves that we did up here. So this thing will be equal to negative 1.92. All right, and that is it for multiplying rational numbers, and I will see you all in the next video.